The other method for solving systems algebraically is known as the substitution method. This uses the idea where if we have an equation solved for a variable, typically y in this case, we can substitute the expression that is set equal to y into the other equation. So let's just work through some examples to see what that looks like. So for example, number 1, or all the following examples, using the substitution method, solve the following systems. So for the first system, we're given y equals -2 and 4x minus 3y equals 18. Now to solve this system, what I'm going to do using substitution method is you take what y is, y equals -2, and you simply just plug it in to this other equation. So we get 4x minus 3 times y. We're given here that y equals -2. So we're going to do minus 3 times -2 equals 18. And now all we have to do is solve for x. So we have 4x minus 3 times -2 is -6. And when we subtract -6, that becomes addition. So we're going to get 4x plus 6. And then we're going to set that equal to 18. Now to solve for x, subtract 6 on both sides. We get 4x equals 12. And then our last step to solve for x is to divide by 4 on both sides. And we get x equals 3. And now, let's just take what we got as our x variable and plug it in to this bottom equation here. So I'm going to do that over here. So we have 4 times x, which is 3, minus 3y equals 18. 4 times 3 is 12, and then we subtract 3y, set that equal to 18. And now to solve for y, I'm going to subtract 12 on both sides. And we get -3y equals 18 minus 12 is 6. And then I'm going to divide by -3 on both sides. And we get y equals -2. So our answer, or our solution to this system, is the point 3, -2. Now looking at example number 2, we are given 2x plus 5y equals 19, and y equals 3x minus 3. So I encourage you to actually pause the video and try to solve this system of equations using what we did up here. So you're going to take y, and you're going to plug it in to this equation. You're going to solve for x, and once you solve for x, you're going to plug x back in to either of these equations to find the point or the solution. And assuming you've done so, let's go through this together. So I'm going to plug in y into this equation. So we're going to get 2x plus 5 times y, which is 3x minus 3. And I'm going to set that equal to 19. And now, to start solving for x, I'm going to distribute in this 5. So we're going to get 2x plus 5 times 3 is 15. And then we're going to carry along that x. And then we're going to subtract 5 times -3. Or we're going to subtract 5 times 3, which is 15. And set that equal to 19. And now I can combine the 2x and 15x, and that is 17x. And then I'm going to carry along that -15, and we're going to set that equal to 19. Now let's solve for x. So I'm going to add 15 on both sides. That cancels, and we get 17x equals 34. And now, to solve for x, I'm going to divide by 17 on both sides. And we get x equals, 34 is actually divisible by 17, and that actually equals 2. And now, all we have to do is take our value of x and plug it in. I'm going to actually plug in x into this bottom equation here. So that's going to make our lives a little bit easier. So we get y equals 3 times x, which is 2. And subtract 3. So y equals 3 times 2 is 6. 6 minus 3, so we get y equals 6 minus 3 is 3. So our solution to this system is 2, 3. That's your answer. Alright, for example 3, we have y equals 4x minus 3 and y equals 3x minus 4. So this system looks a little bit different, but we can still use substitution, and here's why. So both these equations are set equal to y, but what we can do is we can take either equation and substitute y in for either or. So I'm going to take this this bottom equation and substitute it into this top equation. So since y is equal to this expression, 3x minus 4, I'm going to take this expression, 3x minus 4, and plug it directly into y. So we get 3x minus 4 equal to 4x minus 3. And now, all we have to do is solve for x. So to keep our x terms positive, I'm going to subtract 3x on both sides. But if you wanted to, you could also subtract 4x on both sides. You can solve x by doing either or, but I like to do this because I like to keep our x terms. I like to avoid negatives. So that's why I'm doing this. So we're going to carry along that negative 4. 4x minus 3 is just x, or 1x. I'm going to bring down that negative 3. And now to solve for x, I'm going to add 3 on both sides. So we get negative 4 plus 3, which is negative 1. These 3's cancel, and we just get x. So x equals negative 1. Now I'm going to plug in x to this top equation. So we get y equals 4 times x, which is negative 1. And we're going to subtract 3. Now we get y equals 4 times negative 1 is negative 8 minus 3. And this ends up becoming negative 8 minus 3 is negative 11. So our final answer to this problem is the point negative 1 and negative 11. That's your solution to this system. Alrighty. Looking at example number 4, we have x minus y equals 3 and 2x plus y equals 0. So none of these equations are set equal to a variable. So how might we use substitution for this? Well, we can use substitution by taking one of the equations and manipulating them so we can get one of them set equal to a variable. So I'm going to take this first equation, x minus y equals 3, and I'm going to set it equal to a variable. So I'm going to set it equal to x specifically. So to do that, I'm going to bring it up here, x minus y equals 3. So to get it set equal to x, I'm just going to simply add y on both sides. So we get x equals 3 plus y. So now that we have this, I'm going to rewrite our system. So I'm going to rewrite this equation as x equals 3 plus y. And then our bottom equation is going to stay the same, 2x plus y equals 0. So now that this top equation is set equal to x, I'm going to take this expression that's equal to x and substitute it in for x. So we're going to get 2 times x, which is 3 plus y equals 0. Now I'm going to distribute in this 2 to both those terms, so we get 2 times 3, which is 6, plus 2 times y, which is 2y. We're going to add that y there, set this equal to 0. And then 2y plus y is 3y, so we get 6 plus 3y equals 0. And to solve for y, I'm going to start off by subtracting 6 on both sides. We get 3y equals negative 6. And our last step to solve for y, going to divide by 3 on both sides. And we get y equals negative 6, or negative 6 divided by 3 is negative 2. Now we have to take what y is equal to and substitute it in to solve for x. So I'm going to substitute y into this top equation here. So we're going to get x minus y, which is negative 2, equals 3. Well, this, when we subtract this negative 2, that's going to become x plus 2 equals 3. And then to solve for x, I'm just going to subtract by 2 on both sides. And we get x equals 1. So our solution to this system is going to be 1 comma negative 2. Alrighty, so for this last example, I encourage you to pause the video and try this system on your own. And assuming you have given it a go, let's work through it together. So we have y equals x plus 1 and 2y equals 3x. So because this first equation up top is set equal to y, I'm going to take this expression x plus 1 and substitute it in for y because it's set equal to y. So let's do that. X plus 1, bring it in here. So we get 2 times y, which is x plus 1, set equal to 3x. So now we're going to solve for x. And just to do so, I'm going to start by distributing in that 2. So we get 2 times x, which is 2x. And 2 times 1, which is 2. And then we set that equal to 3x. And now I'm going to start off by subtracting 2x on both sides. So we get 2 equals 3x minus 2x is just 1x, so we get x. So x equals 2. And now our last step, we're going to plug in x into either of these equations and solve for y. I'm going to plug it into the top equation because it's already set equal to y, so all we have to do is plug it in and evaluate. So we get y equals x, which is 2, plus 1. So y equals 3. So our solution to the system is 2, 3.